Alright, Chapter 10, Section 2, Arc Processes. Alright, your shield metal arc welding. This is mostly widely used method of general welding application offers due to is metal arc or the manual metal arc or the shake electrode welding. It's an arc welding process with the joining of the metals to produce the heat of the electric arc maintained with the tip of the covered electrode of the metal surface of the joint being welded. Alright. The advantage of shield metal arc welding process can be used with weld most structural alloy steel, including low carbon mild steel, low alloy, heatable, treatable steel, high alloy steel, with the use of stainless steel, such as stainless steel, shielded metal guard welding is joined commonly with nickel alloys, can be used with copper and aluminum alloys. And this welding process can also be used in all position, flat, vertical, horizontal, overhead. Requires only the simplest equipment. The shield metal arc weld lends itself very well to the field work. Figure 1021 shows the schematic drawing of the shield metal arc welding electrode arc workpiece, ground clamp, electrode holder, power source, electrode cable, ground cable. The disadvantage is slag removal of the unused electrode stub with the spatter. Add over the cost of the shield metal arc welding unused electrode stub with the spatter. Account with about 44% of the consumable electrode. Another cost of the entrapment of the slag in form of the inclusion which may have been removed. The process of the core of the covered electrode consists of the electrode solid metal arc rod drawn with a cast of the material with the one fabricated in case of the metal powders of the metallic sheath of the covered rod. Conduct with the electrical current to the arc that provides the filler metal for the joint with the electrode, covering the sheath with the molten metal from the atmosphere for the transfer across the arc and improve the smoothness of the stability of the arc. Arc shielding is obtained with the gas with the result of the decomposition of certain ingredients of the covering. Shield ingredients vary according to the type of the electrode shielding and other ingredients in the covering of the wire control mechanical property, chemical composition, metallurgic structure of the welded metal, as well as the arc characteristics of the electrode. Shielded metal arc welding employs heat of the arc weld with the base metal with the tip of the consumable covered electrode work with the R part of the electrical circuit known to the welding current is shown figure 1022. But the circuit begins with electrical power source that includes the welding cable, electrode holder, ground clamp of the work of the arc welding electrode. One of two cables of the power source attached for the work and the other attached for the electrode holder. 1022 show the elements of the typical welding circuit, the shield metal arc welding AC/DC power control with the ground cable, electrode control cable, AC electrode holder, electrode and electrode work. Welding begins with the electrical arc struck between the tip of the electrode of the work, the intensity of the arc mounts with the tip of the electrode strip of the work beneath the arc with the tiny globe of the molten metal rapidly with the one tip of the electrode transfer through the arc of the steam into the molten weld of the pool, the name of the filler metal, the deposit of the electrode with the progressively consumed the arc moved over the weld, over the work of the appropriate arc length with the travel speed with the melting, fusing portion over the base metal with the adding of the filler metal with the arc process with the center of the arc is one of the hottest for the commercial source of the heat with the temperatures range above 9,000 degrees Fahrenheit and 5,000 degrees Celsius have been measured at the center of the melting takes on place almost instantly with the arc of the contact of metal with which are made in either flat horizontal position metal, the transfer induced with the force of the gravity, gas expansion, electromagnetic forces, surface tension, and force of the for the wheel in other position. Gravity works against the other force. Gravity is the principal force that accounts for the transfer of the filler metal of the flat position welding in other position. The surface of the tension is unable to retain from the molten metal of the slag of the crater. Therefore, the small electrodes must be used to avoid excessive loss for the welding metal and slag. Alright, A has the protected spray, B is the repelled CO2, and C is the gravitational glower. These are three types of free flight metal transfer and welding arc. Gas expansion. The gases are produced with the burning of the volatilization electrode coating expand with the heat of the boiling electrode tip. Coating is sent beyond the metal tip of the electrode control of the direction of the rapid gas expansion direction of the molten metal globe with the welded metal with the hole formed of the base metal. Alright, shield metal arc welding. Continued electromagnetic force of the electrode tip of the electrode contact with the molten metal with the globe with the tip of the therefore the globe is effective with the magnetic force of the acting with the 90 degree with the direction of the current flow. These forces produce the pinching effect of the metal globes, the speed of the separation of the molten metal with the adds at the end of the electrode, particularly helpful with the transfer of the metal with the horizontal vertical overhead position. Electrical force. The force produced with the voltage of the cross of the arc with the pulls of the small pinch off globe of the metal, regardless of the position of the weld. But the force is especially helpful to you with the direct current with the straight polarity. Many are mineral coated electrodes which do not produce larger volumes of gas. So for the tension force of the keep of the filler metal with the smaller slag globes with the contact with the molten base of the welded metal with the crater of the domes. The surface tension that helps to retain with the molten metal with the horizontal, vertical, and overhead welding determine the shape of the welded contours. Equipment. The equipment need for the shield metal arc welding is much less than the complex with the need for the arc welding process. Manual welding equipment they include with the power source, the transformer, the DC generator, DC rectifier, electrode holder, cable, the contact with the typically hammer, the wire, and electrodes. 5. The welding parameters. Welding voltage, current with the travel speed and current and travel speed are very important, but the quality of the deposit shield metal arc weld deal. The figures 1024 through 1030 show the travel speed of the limited electrodes listed in table 1. 10.1, page 1030 for the table of 10.1 show for the voltage limits of the shield metal arc welding. So in figure 1024, you have the travel speed with the current level of 1/8 of an inch diameter E6010 small shield metal arc welding electrode dash line. The travel speed limited to the determined amount of the undercut and bead shape. Travel speed in inches, then current in amperes. Then you have travel speed in inches and then current in amperes for the travel speed with the current level of 1/8 of an inch diameter E6011. The dash line show the travel speed limits to determine the amount of the undercut and bead shape. And then you have the current in ampere, the travel speed in inches squared, inches a minute. The travel speed limited for the current level of 1/8 of an inch diameter 6013. Shield metal arc weld dash line travel speed limited for the determined amount of the undercut and bead shape. And then 1027 show the travel speed limited for the current level of U the 1/8 of an inch diameter E7018 with the dash line travel speed limited for the determined amount of the undercut and bead shape of the current in amperes. And then travel speed. Your travel speed limits for the current level of the 1/8 of an inch diameter 6024 shield metal arc line dash line show for the travel speed limited for the show for the determined amount of the undercut and bead shape. And then the figure 1029 show for the travel speed with the current level of 532 inch diameter E8018 dash line travel speed limited for the determined amount of the undercut and shape. And current in amperes, figure 1030 show for the travel speed with the current level of 1/8 of an inch the E11 11018 shield metal arc with a dash line travel speed limited to determine the amount of the undercut and bead shape. Table 10 shows the established voltage limits, and then the process required with the sufficient electrical current with the bolt of the electrode for the proper amount of the base metal with the appropriate gap between the tip of the electrode base metal with the molten weld of the part required with the necessary with the constituency with the side of the tap of the electrode with the shield metal arc weld to define the arc voltage requirement with the overall range of the 60 to 40 volts. Amperage required with the overall range of the 200 to 550 amps. The current may be either alternating direct with the power source must be able to current with the current level over order to respond with the complex variable of the welding process itself. Alright, covered electrode. In addition, with establishing of the arc with the supplying with the filler metal with the welded deposit of the electrode introduced the other materials in or around the arc, depending upon the type of the electrode being used, the covering of the perform one or more of the following functions. Provide with the gas to shield the arc with the prevent of excessive atmosphere with contamination with the molten filler metal with the travel across the arc. Provides a scavenger deoxidizer fluxing agent for the cleanse of the weld to prevent excessive grain growth in the welded metal. Established with the electrical characteristics of the electrode. Provides a slag blanket to protect the hot weld metal from the air. The enhance the mechanical properties to be shape of the surface of the cleanliness of the weld metal. Provides a means of adding an alloy to the chain of the medical properties of the welded metal. Functions 1 and 4 prevent the picking up of the oxygen and nitrogen of the air for the molten filler metal of the arc stream of the welded metal solidified with the cools. The covering of the shielded metal arc electrodes is applied with either the extrusion or the dipping process. With the extrusion, with is more widely used with the dipping process. With is primarily used with the casting of the fabricated core rods. In either case, the covering with the contained with more shield than gas with scattering deoxidization material. Most shielded metal arc welders have a solid metal core, with some of them made with a fabricated with the composition consisting of the metal powder skin cave with the metallic sheath. In this later case, the purpose of some of the even all the metal powders and produce the alloy welded deposit. In addition, with improving the mechanical property of the welded metal, the covering of the electrode of the can be designed for the welding and alternating curve of the AC with the welding arc goes out with the reestablished each time the current reverses its direction. Good arc stability necessary to have the gas arc stream and the remain with the ionized during the reversal of the current of the ionized gas makes the possible reignition of the arc gas of the readily ionized are available the variety of the compounds including those that contain the potassium and the incorporation of these compounds with the electrode covering enables the electrode to operate with the AC. To increase the deposition rate with the covering of the sum of the carbon low LSG of the electrode with the iron power. The iron power is another source of the metal available with the deposition addition obtained with the core of the electrode. Presence of the iron power covering may also make the efficiency use of the arc energy of the metal power of the iron frequently used after the mechanical properties of the weld metal. Thick coverings electrode relatively large amount of the iron powder, increase the depth of the crucible, the tip of the electrode, the deep of the crucible, the helps create the contain the heat of the arc, the maintain with the constant arc length, the Evening drag technique. The iron and other metal powders are added relatively large amount with the deposition rate and welding speed, usually increase with the iron powder electrode. With the thick coverings reduce the level of skill level needed to weld. The tip of the electrode can be dragged along the strip of the arc while maintaining the welded electrode. The reason for the heavy iron powder electrode frequently are called the drag electrodes. Deposition rate with a higher because of the slag solidification slow of these electrodes are not suitable for the out of position use. Alright, electrode classification system with the shield metal arc weld classification with the E with these three numbers involved with the dash of either 15 or 16 with the these E designate the material of the electrode with the three digits indicate with the composition. Sometimes the letters found with the three digits of these letters amount modification sim. Standard composition 15 and 16 specify the type of the current which of the electrodes may be used with the designation indicate with the electrode usable for the all position flat horizontal vertical overhead. The 15 indicate with the covering of the electrode with the lining type lime type of the contained with a large portion of the calcium alkaline earth material. These electrodes are usable in the DC for reverse polarity only. Designation 16 includes the electrode with the lime titanium and covering with a large portion of the titanium bearing metals. Covering these electrodes are also contain readily ionizing elements with the potassium to stabilize the arc of the AC. Our shield metal arc welding continued chemical requirement. The AWF divided the shield metal arc welding in two groups: the mild steel with low alloy steel with the E60 and the E60 and E70 electrode mild steel with the specification for the chemical requirement. The E70 electrode listed with the AWS 51 allow the wide variation of the composition of the deposited welded metal with no specified with the chemical requirement. The E60 electrode with the low alloy specification contained with the electrode classification E70 120X with these those for the have the suffix indicating chemical requirements. The last electrode with the E7010A and the E8018C1 composition low alloy 70 electrodes is controlled much more closely than the mild steel 70 electrodes. The low alloy electrodes, low hydrogen classification of the EX50X, the EXX15, the EXX16, EXX18 require special handling of the and to keep the coating for the pickup of the water manufacturer recommendations of the storage repacking. Repacking must be filed with these electrodes. The AWS 55 provides specific listing with the chemical requirements. Welded metal property, the AWS require the deposit welded metal to have the minimum tensile strength of 60 to 100,000 pounds with a minimum elongation of 20 to 35%. Arc shielding action illustrated in figure 1031, essentially with the same with the differential type of electrode with specified method of shielding with the volume of the slag with the produce the various type of the type bulking of the covering of the materials similar to the electrode converted with the gas heat over the arc only with a small amount of the slag is produced. The type of the electrode depends largely upon the gas shield to prevent atmospheric contamination, while the metal such with electrodes can be identified with a completely light layer of slag covers the bead. The show in 31 show the shield metal arc welding electrode cover the core wire of the shield metal atmosphere molten welded solidified slag weld base metal welded metal slag droplets and penetration depth. The electrode with other extremely bulk covering with the convertible with the slag of the arc heat with only small volume of the shielding gas produced with a tiny globe of the metal with the transfer of the craft of the arc with entirely coated with a thin film of the molten slag with the slag flows with the welded puddle with the surface with a lighter than the metal. It solidifies after the metal with the solidified with the weld metals with the electrodes identified with the heavy slag deposit with the completely cover the welded bead between the extreme of the wide variety of the electrode type with a different combination of the gas and gas shielding. Alright, the variations amount of the slag and gas shielding are also influence welding character. The different type of the covered electrodes have the heavy slag of the high amperage of the higher have high deposition rate with these electrodes ideal with making large bead with a flat position with the electrodes. They develop the gaseous arc shield with a light layer, but they also carry with the covered low amperage with the low deposition rate with the electrodes produce a smaller welded pool with the better suited with making weld with the vertical overhead position because of the use of the difference of welding characteristics. One type covered electrode will usually be best suited for the given application. Alright, 10.9, your gas tungsten arc welding. Gas tungsten arc welding is a process with the joining of the metal with the heating of the arc with the tungsten of the non-consumable electrode with the shielding gas is usually normal argon. The tag welding normally done with a pure tungsten alloy rod, multiple electrodes, sometimes with the heated welded molten metal with the tungsten area. Electrodes are shielded with the atmosphere covering their gas fed with the electrode hole of the filler metal may or may not be added. A weld is made with applying with the arc due to the touching of the touching of the workpiece for the filler and metal are melted and joined to the metal solidified. The process is similar to the arc welding process that is in the heat with the generator of the arc between the non-consumable electrode workpiece. The equipment electrode type distinguishes TIG from other arc welding process. Figures 1032 show the gas TIG or welding direction of travel current conductor shielded gas non-consumable tungsten electrode gas shield arc gas nozzle welding rod guide. Alright, equipment. The basic feature of the equipment of the TIG welding or the drum of the TIG 1033 with the major components required for the TIG welding are the welding machine, power source of the welding electrode, hold the tungsten electrode, the shielding gas supply with the controls. Several operational accessories available include the foot pedal, rheostat with the current while welding, water circulating system with the cooling electrode and the arc timers. Note the AC and the DC power units with the built with the high frequency generator designed specifically with the TIG welding of the automatically controlled gas and water flow with the water beginning with the ends. when welding begins and add. The electrode holder is water cooled with a supply of the cooling water is necessary. The electrode holders are made of so that the electrode of the gas nozzle readily will be chained with the mechanism of the TIG welding equipment may be the device for checking and adjusting the welding torch level, equipment of the work handling with provisions in initiating the arc and controlling the gas of the water flow and the filler metal feed mechanism. Figure 1033 shows the gas tungsten arc welding arrangement. The water-cooled welding torch with the cooling within the air gas shielding inadequate. The tungsten electrode gas passage workpiece insulating sheath. The electrode conductor, the electrode holder, welding machine shield, gas and air gas supply. Advantage gas tungsten arc welding, most popular method of welding aluminum stainless steel with the nickel base alloys produced for the top quality welded almost all metals and alloys for the used by the industry. Process provides more precise control with the welding any other arc welding process because of the arc with the heat with the filler metal dependently controlled. Visibility excellently because of no smoke when the fumes are produced during the weld. There are no slag spatter with the clean between the passive and the complete weld. The take-up welding also has reduced distortion of the welding joint because of the concentrate of the heat source of the gas tungsten arc welding is very good for the joining of the base metal because of the excellent current of the heat input of the oxyacetylene welding. The heat source in addition with the filler metal is separately controlled because of the electrodes non-consumable. The process can also be used with the fusion alone without addition of the filler metal. It can also be used with almost all metals and generally not used for very low melting metals such as solars, lead, tin, or zinc alloys, especially useful for joining aluminum, magnesium, which form refractory oxides. Also, reactive metals with the titanium, zirconium, with which the dissolved oxygen, nitrogen become brittle if exposed to air while melting. In a very critical surface application for the very expensive metal of the parts of materials should be carefully cleaned with the surface of dirt and grease the oxides before welding. Alright, your disadvantage. TIG welding is expensive because of the arc of the travel speed of the weld metal deposit are lower than some of the other methods, similar with the limitation of the gas tungsten arc metal are process slower than consumable arc welding process clearance for the molten chunks of the electrode of the weld with the cause of the contamination of the result of the tungsten inclusion of the hard brittle, as well as the hot filler rod of the air using improper welding technique for the welded metal combination. An air gas shield of the tungsten arc costing added total cost of the welding compared with the other process of the argon helium using shield of the arc relatively expensive. 5. Equipment costs greater than other processes of the shielding metal arc welding, which requires less precise controls. For these reasons, the gas tungsten arc welding process is generally not commercially competitive with the other commercially competitive with the other process of the heavier gauge of the metal, if they can be readily welded. The shield metal arc welded submerged or gas metal arc welding process with adequate quality. Process principle before welding begins. Oil, grease, and paint with rust, dirt, and other contaminants must be removed with the welded area. They must be accomplished by the mechanical means of the use of the vapor or liquid cleaners. Stroking the arc may be done any of the following methods: touching the electrode to the work momentarily, quickly withdrawing it, using an apparatus that will cause the spark to jump from the electrode to the work, and also using an apparatus to initiate the maintained small pilot arc, providing an ionized path of the main arc. High frequency arc stabilizers required with the alternating current with the U if the provided with the type of the arc stabilizing described in 2B above the high frequency of the initiation occurred with a high frequency high voltage signal prevent both the welded current, high voltage, low current ionizing shield the gas between the electrode and the workpiece, which make the gas conductive and initiate the arc. And air gases are not conductive in the unit until ionized. For DC welding of the high voltage frequency voltage cut off after the arc initiation. However, the AC welding is usually remained during the welding, especially with the welding aluminum. When welding manually, once the arc is started, the torch is held at the travel angle of 15 degrees. The mechanized welding and electrode hold their position vertically to the surface. At the start of the manual welding arc is moved in a small circle until the pool with the molten metal formed with the establishment means with the suitable welded pool with the important but the welding will not proceed ahead of the pub. The one adequate fusion is obtained when the welding is made. Gradually move the electrode along with the part that is to be welded the metal adjoining surface of the solidification of the molten metal with the follow of the progression of the arc along the joint and complete with the welding cycle. The welding rod and torch must be moved aggressively smoothly so far that the welding pool, hot welded rod, and the hot solidified welder are not in competition into the air. They will contaminate the welded metal area. Heat affected zone. Large shielding metal gas cover that will prevent the exposure to the air. Shielding gas is normally argon. The welding rod is held at an angle of about 15 degrees with work with the surface slowly fed with the molten pool during the welding. Hot end of the welding rod not removed with the inert gas shield. The second method is to press the welding rod against the work in line with the weld. The melt of the rod along with the joint edge of this method is often called the multiple pass welding of the V groove joint. The third method is frequently in the welding surface of making the large welds to feed filler metal consistently with the molten welded pool by oscillation of the welding rod arc and side to side. Welding rod moves in one direction of the arc, move the opposite direction of the welding rod is at all times near the arc of the feeding of the molten metal. The filler metal is required for the automatic welding of the welding rod. Wire the fed mechanically through and guide the molten welded pool. Selecting of the welded position determine the mobility of the weldment and availability of the tool fixture of the welding cost, the minimum time therefore the four costs. Producing a weld usually achieved in the flat position, making in the wet rate ration deposition rate with obtained in the position becomes the large volume molten metal can be supported. Also an acceptable shape, the reinforcement is easily obtained within this position. Good penetration can be achieved with the vertical up position, and but the rate of the welding is slower because of the effect of the gravity of the molten welded pool. Penetration vertical dam welding is poor with the molten metal drops and lack of the fusion curves. Unless the high welding speeds are usually depositing a thin layer of the welding metal. The welding torch is usually pointed forward at an angle of 75 degrees of the welding surface vertical of the flat position to greater angle of the cause of the aspiration of the air, the shielding gas, consequently oxidation of molten metal, welded metal. Alright, joints that may be welded to the process include all the standard type of the square groove and the V groove joint, the T joint, lap joints. As rule, but it is not necessary to bevel the edge of the base metal that is 1/8 of an inch or less, and thicker base metal is usually beveled. The filler metal is always added. Gas tungsten arc welding process can be either the continuous weld, the intermittent weld, the other spot welds. It can be done manually or automatically by machine. Three major operation variables to summarize briefly are welding current, voltage, power source, the sum of the characteristic electrical composition, current carrying capacity, and shape. Shielding gas, welded grade, argon, helium, mixture of both. Filler metals are generally similar to the metals being joined, suitable with the intent of service. Welding is stopped by shutting off the current with a foot or hand control switches in the perimeter of the welder to start and adjust the stop of the welding current. With this allow for the welder to control the welding current to withstand with good fusion penetration. Welding may also be stopped with withdrawing the electrode from the current quickly. This can disturb the gas shielding exposed with the tungsten welding pool to oxidation. Filler metal, the base metal with the thickness of the joint is determined whether no filler metal needs to be added to the joints, and when filler metal is added during the manual welding, it is applied with the manually feeding of the welding rod to the molten pool ahead of the arc, but one side of the center line of the technique of the manual TIG welding is shown in figure 1034. So the 1034 shows the manual gas TIG welding direction weld to develop with the puddle, move the torch back, add filler metal, withdraw rod, move torch to the leading edge of the puddle. Alright, your plasma arc welding. General plasma arc welding is the process of the columns over the joining of the metal to produce the heating of the constricted air with the electrode with the workpiece for the transfer of the arc of the electrode with the constricting knob with the non-transfer arc. Shielding is obtained with the hot ionized gases issuing with the orifice may be supplemented with the auxiliary source of the shielding gas shield with the gas may be in the air with the gas mixture, and pressure may not be used in filler metal may or may not be supplied with the plasma arc welding process shown in figure 1035. 1035 shows the process diagram of the keyhole mode, the orifice constriction plasma stream of the shielding gas, solidified metal with the molten metal with the base metal with the filler rod with the coolant, shielding gas and tungsten electrode. Equipment. Your power source with the constant current with the dropping of the characteristic power source with the supply with the DC welding current is recommended. However, the AC/DC type of the power supply can be used. It should have the open circuit voltage of 80 volts that have the duty for the cycle with 60%. Desirable the power source to have a built-in contactor provision for the remote control circuit can adjust remote control current adjustment for the welding vary with the thin metal that should have the minimum amperage of 2 amp with the maximum of 300 for the adequate most plasma arc welding application. Welding torch of plasma arc welding is similar to the appearance of the gas tungsten arc touch torch, but much more complex. All plasma torches are water cooled at even lowest current range of the torch of this become the arc contained with the inside of the chamber of the torch, where it is generated with considerable heat with the water flow with the interpreted with the briefly with the nozzle may be melt. The nozzle may melt. Cross-sectional plasma arc torch that has been shown in the figure 1036 with during the non-transferred period. The arc will be struck between the nozzle and the tip of the orifice with the tungsten electrode. Manual plasma arc torches are made at various sizes starting at 100 amps to 300 amps. Automatic torches from machine operation are also available. 1036 with the cross-section plasma arc torch head. Electrode collet, electrode cap, plasma shielding gas, water current in, water current out, and negative and positive. Handled nozzle welding tip. Right, a torch utilized with the 2% of the authority of the tungsten electrode, similar with the gas tungsten arc welding. The tungsten electrode is located with the inside of the torch, with almost impossible to contaminate with the base metal. With the control console, the quad with the plasma arc welding, plasma arc torches are designed to connect with the control console rather than the power source of the console. Included with the power source of the pilot arc, with the delay with the timing system, with the transferring with the pilot arc, with the transferred arc with the water gas net value, with the separate the flow medium of the plasma gap, with the shielding gap of the console usually connected to the power source. The main operate with the contactor, also with the containment of the high frequency arc starting unit with the non-transferred pilot arc power supply with the torch protection circuit with the ammeter, and the high frequency generators used to initiate the pilot arc with the torch protective devices include water, plasma, gas pressure with the switcher with the interlock with the contactor wire feeder. Maybe used with the machine with the automatic welding must be constant speed type. The wire feed must be speed adjustment covering the range of the 10 inch per minute to 125 inches per minute with the feed speed with the advantages of the advantages and major uses. Advantages of plasma arc welding over the compared with the gas tungsten arc welding over the stem of the fact that the plasma arc welding has a higher energy with the concentration, the higher the temperature of the concentrate due to cross-sectional area with the velocity of the plasma jet created with a higher heat content with the other advantages based on the stiff column type arc of the forming from the plasma that does not flare with the like of the gas tungsten arc. Those two factors provide with the following advantages. The torch work distance of the plasma arc is less critical than the gas tungsten arc welding. This is important for the manual operation since it will give the welder more freedom to observe the control weld. B. The high temperature of the high heat concentration of the plasma allow the keyhole effect with the provide with the complete with the penetration single path of the welding. Many of the joint with the high operation of the heat affected zone with the form of the welded area more desirable. The heat affected zone is smaller than the gas tungsten arc. And the weld tends to have more parallel side with reduced angular distortion. Alright, the higher heat of the concentration plasma jet allow with a higher trouble speed of the plasma arc with a more stable and is not easily deflected with the closest point of the base metal with a greater variation in the joint alignment is possible. The plasma arc welding important to make the root pass of the weld on the pipe of the other side on site with the weld to join with the plasma welding the deeper penetration capabilities produce the narrow weld. This means the depth of the width ratio has more advantages. The use of some of the major use of the plasma arc welding application for the manufacturing of the tubing higher protection rate of the base of the travel speed with the result of the plasma over the gas tungsten arc weld tubing may be the stainless steel, titanium, and other metal that being produced with the plasma process with the higher production rates of the previously with the gas tungsten arc welding. Most applications of the plasma arc welding in low current range that have between 100 ampere to less. The plasma can be operated with extremely low current with the alloy welding of the foil thickness material. Plasma arc welding is also used with making small welds on weldments of the instrument, manufacturing other small components made of thin metal. It's used with making butt joint with the wall tubing. This process is also used to do work similar with electron beam welding, which is lower equipment cost. Plasma arc welding is normally applied with a manual welding process, but with its use of the automatic machines and machines application, manual application is most popular. Semi-automatic application is not useful. Normal methods of applying plasma arc welding are manual, machine, and automatic. Plasma arc welding process and all position welding process. Table 10.2 show the welding position capabilities. Flat, horizontal fillet, horizontal, vertical, overhead, and pipe fixed. The plasma arc welding process is able to join practically all commercially available metal, but it may not be the best selection of the most economical process for the welding of some metals. Plasma arc welding process will join all metal with the gas tungsten arc welding process will weld. This is illustrated in figure table 10.3. Regarding thickness of the range of the weld of the plasma process, the keyhole mode of the operation can be used with the plasma joint. A jet can penetrate with the joint, but then this mode can be used with welding metal material of the 1/16 of an inch. Thickness ranges vary with the different metal. This metal melted mode with the welded material is up to 0.02 of an inch thin, up to 1/8 of an inch. Using multiple techniques, unlimited thickness of the metal can be welded. Note, but the filler rod is used for making the weld of thicker metal material. Refer to table 10.2 for the base metal thickness ranges. And then show the 10.3 show the base metal weldable with the plasma arc welding. And then 10.4 with the base metal thickness ranges. Single pass P-hole, multiple pass in mode. Alright, your limitations of the process. The major limitation of the process have to do with the equipment of the aperture of the torch, with the delicate, with the complex, with the gas tungsten arc torch. Eventually, lowest rated torches must be water cooled. The tip of the tungsten with the alignment of the orifice nozzle is extremely important, but must be maintained with a very close limit. The current level of the torch cannot be exceeded without damaging the tip of the water cooling patch for the torch are relatively small. For this reason, the water filters deionized water are recommended for the low current and smaller torches. The current control console added another piece of the equipment to the system. The extra equipment makes the system more expensive and may require a higher level of maintenance. Principal operation. The plasma arc welding process is normally compared with the gas tungsten arc process. If an electrical arc in between the tungsten electrode, the work is constricted in cross-sectional area with the temperature increases because it carries out the same amount of the current. But the constricted arc is called the plasma or fourth state of matter. Two modes of operation: the non-transferred arc and the transferred arc. If the transferred and in the non-transferred mode, the current flow is from the electrode inside of the torch of the nozzle contained with the orifice back to the power supply, and is used for the plasma spraying and the generating heat in non-metals. In transferred arc mode, the current is transferred in from the tungsten electrode inside of the welding torch through the orifice to the workpiece and back to the power supply. The difference between the two modes of the operation shown in Figure 1037, the transferred arc mode is used the welding metal to the gas tungsten arc process is shown for comparison. Show the gas tungsten arc welding, tungsten shielded gas work, and then it shows the plasma work, the plasma arc shielding gas work, and transferred, non-transferred. Alright, 10.10.3, plasma arc welding continued. Plasma is generated with a constricting electrical arc passed through the orifice of the nozzle of the ionized gas, with also forced through this opening with the plasma have the stiff column area with the form of the parallel side with it is done. Not to flare with the same manner with the gas tungsten arc welding, gas tungsten arc, the high temperature over the arc directed toward the work will melt the base metal, the surface of the filler with the metal with the add to make the weld. In this way, plasma acts as extremely high temperature with the heat source of the form of the molten welded puddle. This is similar to the gas tungsten arc. The high temperature for the plasma, however, the cause of this to happen with the faster for the known with the molten metal mode of the operation. Figure 1036 with page 1039. A cross-sectional view of the plasma torch head. The high temperature for the plasma constricted arc and the high velocity of the plasma jet with the provide with the increased heat with the transfer rate with the over tungsten arc with the welding while using the same current with the result of the faster welding speed with the deeper the weld the penetrate for the method of the operation. Use for the welding extremely thin material with the welding multiple pass screw with the weld and fillets. Another method of weld with the plasma with the keyhole method of the welding of the plasma joint penetrate with the work piece for the forms of the forms a hole or keyhole surface tension for the first forces molten base metal with the flow around the keyhole to form a weld. The keyhole method can be used only on joints when plasma can pass through the joint. It is used the base metal with 1/16 to 1/2 inch of the thickness of the effect of the base metal with the composition of the welding gas. The keyhole method provides full penetration single pass welding, which may be applied with the manually or the automatically in all positions. Your joint design is based on the metal thickness for the determined with the two methods of the operation of the keyhole method. The joint design restricted with the full penetration of the preferred with the joint design with the square groove with no minimum the root opening of the four root pass work with the particularly with a heavy wall pipe with the U groove with the design is U for the root face should be 1/8 of an inch to allow the full keyhole penetration for the melt-in method of the operation welding thin gauge of the 20,000 of an inch to 100,000 of an inch metal with a square groove weld should be all utilized with the welding all thicknesses of the 5,000 of an inch to 20,000 of an inch. The edge flanging joint should be used. The flanges are melted to provide filler metal with the making the weld. When using melted and mode for the operation from the thick material, the same general joint detail with the shield metal arc welding, gas tungsten arc welding can be employed. It can also be used for fillets, flange welds, all the type of the groove welds, etc. And lab joints, arc welding, spot welding, or seam welding. Figure 1038 shows the various joint design that can be welded with the plasma arc process. Alright, 7. Welding. Circle with the current of the welding. Circle with the plasma arc welding more complex with the gas tungsten arc welding. Extreme with the component with the required with the control circle with the starting with the top of the electric over the plasma arc with the chain with the power source with the U with the two gaseous systems. One supply with the plasma gas with the second with the shield gas. The welding current plasma arc welding is shown. Figure 1039. Direct current with the constant current with the U with the alternating current is used only on a few applications. It shows the joints, various joints of plasma arcs. And 1039 shows the circuit diagram of the plasma arc with the equipment illustration filler rod, the base metal with the torch with the work lead with the foot pedal optional electro lead. Oil, water, blast, drain, shield metal, shield gas, plasma gas, power supply, and a quality of the common faults. Tips for using this process: the tungsten electrode must be precisely centered located with the respectively orifice of the knob of the pilot of the arc. With the current that must be kept with sufficiently low, just high enough to maintain with the stable the pilot arc. Welding extremely thin metal with the foil range of the pilot arc may be all necessary. When filler metal is used with the add with the same manner with the gas tungsten arc welding, however, with the lower torch to work distance a little greater than more freedom than adding filler metal. Equipment must be properly adjusted to using the shielding gas and plasma arc with the right proportion for the proper gap. It must also be used. The heat input for this important plasma gas flow also has an important efficient effect. These factors also shown in Figure 1040. The filler metal and other equipment. The filler metal is normally used except for these when the welding thinnest metal, but the composition of the filler metal should match with the base metal. But the filler metal depends on the base metal thickness for the welding current. The filler metal is usually added with the puddle with manually, but it can be added automatically. Here, plasma shielding and shielding gas and air gas with either argon helium mixture with the shielding arc with from the atmosphere. The argon is more common because of the heavier provides the better shielding at lower flow rates through flat vertical welding and shield gas flow with 15 to 30 cubic feet per minute. Insufficient overhead position with welding requires slightly higher flow rate. Argon is usually plasma gas flow rate of 1 cubic foot per hour, up to 5 cubic per hour for the welding, depending on the torch type of the application. Active gases are not recommended for plasma, and adding cooling water is required. Your quality and deposition rates are variable. The quality of the plasma arc welding is extremely high, but usually are higher than the gas tungsten arc welding because of the little or no possibility of the tungsten inclusion of the weld. Deposition of the rate of the plasma arc welding are somewhat higher than other than gas tungsten arc welding. They are shown in the curve of the Figure 1041. Welded schedules for the plasma arc process are shown with the data of the tables and 5 of the process variable. The plasma arc welding are shown in Figure 1041. The most variable shown with the plasma arc with the similar to the other arc welding process with the 2 mixed temperature with the plasma gas flow with the ore for the diameter of the nice level with the major variable to accept the considerable control of the process. Minor variables are generally fixed for the optimum condition for the given application. All variables should be able to the welding perceive the variables such as the angle of the setback of the electrode type are considerable fixed for the application of the plasma arc process. Does not respond differently to these variables than does to the gas tungsten arc process. The standoff of the torch work distance then less expensive, less sensitive with plasma, but the torch angle of the welding parts is unequal. The thickness is more important than gas tungsten arc welding. And 1041 shows the deposition rate variation of the process of the welding current that may be applied pulse to the gain with some of the advantage of the pulse provided with the gas tungsten arc welding high current pulse with the maximum penetration, but it's not in full time and allowed with the metal solidification. This gives it a more easily controlled puddle without position work. Pulsing can be accomplished by the same apparatus used with the gas tungsten arc welding program. Welding can also be employed with the plasma arc welding in the same manner as the used with the gas tungsten arc welding. The same power source of the programmable abilities used offer the same advantage for the certain type of the work with the complexity of the program depending on the needs of the specific application. Additional program welding current with the often necessary to program the plasma gas flow with a particular important when closing with a keyhole, which is required to make the root pass and welding joint 2 pieces of pipe. The method of feeding of the filler wire with the plasma is essential the same as with the gas tungsten arc welding hot wire concept that can be used with the means of low voltage current supplied with the filler metal preheat or prior to going into the welded puddle. And then it shows Table 5 shows welding procedure schedule, plasma arc manual application. Your carbon arc welding. Carbon arc welding is the process of the joining of the metal with the produce the heating of the arc between the carbon electrode of the work of the shielding gas. The pressure for the filler metal may or may not be used. The electrode of the carbon electrode ranges from 1/8 to 7/8 of an inch in the diameter. The bake of the carbon electrodes lasts longer with the graphite electrodes. The Figure 1042 show the typical air-cooled carbon electrode holder. The water-cooled holders are available to use with the large sizes of electrodes. Adapters can be fitted with regular holders, permanent accommodation with the large electrodes. Machine, the direct current welding machine, either with the rotating of the rectifier type of the power source for the carbon arc welding process. Welding circuit with the welding current. With the welding current circuit with the carbon arc welding is the same as with the shield metal arc, with the difference of the aperture of the special type of the electrode holder is usually only holding the carbon electrode with the type of the holder is usually because the carbon electrodes become extremely hot and used for the conventional electrode holder will be not efficiently hold or transmit the current to the carbon electrode with the power source of the conventional constant current with the type of the drooping voltage ampere characteristics normally at 60% of the duty cycle with the power source that utilized with the power source should have the voltage rating of 50 volts since the voltage is used when welding copper and within carbon arc. Single electrode carbon arc welding is always used with the direct current with the electrode negative straight polarity. After the carbon steel arc of the positive pole with the end is the pole over the maximum heat with the electrode where positive of the carbon electrode would erode very rapidly because of the higher heat and would be used the black carbon smoke with excessive carbon which could be absorbed by the weld of the melting and alternating currents. Not recommended with the single carbon arc welding. The electrode should not be adjusted with the compensating for the erosion with the carbon from 3 to 5 inches of the carbon electrode should be trued through the holder towards the arc. Your advantage is major U with a single electrocarbon arc welding process that is no longer widely used for the welding competence. It can be used for the high current to develop the high heat usually required by the also used for the making the bronze repair with only cast iron parts. When welding thinner metal with the process that used for making the autogeneous weld with the welded without added filler metal with the carbon arc welding is also used for the joining for galvanized steel. But in case of the bronze filler rod is added by placing it in between the arc and the base metal. The carbon arc welding process has been used almost entirely with the manufacturing method of applying it on all position welding process for the carbon arc welding is primarily used the heat source for the generator of the weld pellet, which can be carried out in any position. Table 10.6 shows the normal method of applying carbon arc welding. Table 10 shows the welding position capabilities. Method applying with the carbon arc process, manual, semi-automatic, automatic welding positions, and flat, horizontal, vertical, overhead, and pipe is weldable metals. Since the carbon arc is usually primary for the heat source of the generator of the welded pellet, can be used for the on metals that are not affected by carbon pickup with the carbon monoxide, carbon dioxide arc atmosphere. It can be used with welding steel and non-ferrous metals and for surfacing. Steels. The carbon arc welding continues steel. The main use of the carbon arc welding is steel for the making the edge of the weld with additional filler metal. This is done with the making of the thin gauge of the sheet metal work over the tank for the edge of the work with the pitted with the close for the gather. Use an approximate flux of the galvanized steel that can be brazed with the carbon arc with the bronze welding rod is used for the arc of the direction within the rod with the galvanizing if it's not burned off with the steel sheet. Of the steel sheet, the arc should be started over the welding rod with the starting block over the lower current or arc length, and the rapid travel speed should be used with the welding rod should melt with the wet and galvanized. Your iron cast iron may be welded with a carbon arc with a cast iron welding rod. With the casting should be preheated at about 1200 degrees Fahrenheit with a slowly cool with the machine weld desired. Copper straight polarity should always be with the carbon arc welding of the copper. The reverse polarity to produce the carbon deposit of the work with inhibit the fusion of the work should be reheated with a range of 300 to 1200 degrees Fahrenheit depending upon the thickness of the part. If this is impractical, the arc that should be used to locally preheat the welded air with a high thermal conductivity of the copper cover the heat that is conducted away from the point of the welding so rapidly that it is difficult to maintain the welding heat without preheating of the root opening of 1/8 of an inch is recommended. Best results obtained with a higher travel speed with the arc length with the direction of the welding rod with a long arc length should be used and permit carbon with the electrode combined with the oxygen to form carbon dioxide, which provides some of the shielding of the welding metal. Your principles of operation: carbon arc welding is shown figure 1043 with using a single electrode with the arc between the end base metal with the oldest arc process is and now popular today. Direction arc travel with the arc stream, filler metal base metal arc core, and electrode shown in the figure 1043. The process with the carbon arc welding. In carbon arc welding, the arc heat makes the carbon electrode with the work melts with the base metal with the wind required with all the melts with the melts of the filler rod. All molten metal solidified with the weld is produced with the non-consumable graphite electrode arose rapidly with the disintegrating produced with the shielding atmosphere of the carbon monoxide, carbon dioxide gas. The gas is partially displaced in the air with the arc of the atmosphere with the prohibit the oxygen nitrogen from coming in contact with the molten metal. Filler metal when used there in some of the brain composition of the base metal with the bronzing of the filler metal can be used for the brazing of the brazing or braze welding. The workpiece must be free of the gas, oil, scale, paint, and other foreign material. The two pieces should be clammed together tightly with no root opening. They may be tacked welded together. Carbon electrodes 1/8 of an inch, 5/16 of an inch diameter, maybe depending upon the current required for the welding, and end of the electrode should be prepared with long taper. The point diameter of the point should be on half of the electrode. For steel of the electrode that should protrude with 4 to 5 inches from the electrode holder. A carbon arc may be struck with the bringing of the tip of the electrode into the contact with the work, immediately withdrawn into the correct length of the welding and the general arc length with between 1/4 to 3/8 of an inch. In space, the arc length is too short, there is likely the excessive carbonization of the molten metal resulting in brittle weld. When the arc is broken, if for any reason it should not be restarted directly up on the hot weld metal. This could cover the hard spot of the welding of at the joint. At the point of the contact, the arc should be started with the cold metal on one side of the joint and then quickly return to the point where welding is to be resumed. Alright, when the joint required with the filler metal of the welding rod is fed into the molten weld, it will pull with the one hand with the arc, with the manipulate with the other, with the arc is direct with the strip of the work, will gradually move along with the joint, constantly maintaining the molten pool with the welding rods, add with the same manner with the gas tungsten arc welding process along with the welded joint with the addition of the welding rod must be tied or to provide size for the shape of the welding metal bead desired welding vertically or overhead with the carbon arc with the difficulty because of the carbon arc welding essentially puddling process. Welding joints should be backed up, especially when in case of the thin sheets and to support molten metal welded pools to prevent excessive melt through. For outside corner welds, the 14 to 18 gauge steel sheath, the carbon arc can be used to weld two sheaths together without filler metal. With such welds are usually smoother and more economically to make more than shield metal arc welds are made under similar conditions. Alright, welding schedule. The welding schedule for the carbon arc welding galvanized iron using silicon brazed filler metal is given in table 10.8, and the short arc should be used to avoid damaging for the galvanized arc, but must be directed on the filler wire which will melt flow onto the joint of the welding copper of the higher arc with the voltage using shall be scheduled in table 10.9. Table 10.10 show for the welding current the current to be used each side of the two types of carbon electrodes. Carbon electrode welding procedure schedule galvanized steel brazing. Brazed welding procedures galvanized schedule for carbon arc welding copper, and welding current for the carbon electrode type. Alright, variations of process. There are two important variations for the carbon arc welding. One is twin carbon arc welding, the other is carbon arc cutting and gouging. Twin carbon arc welding is an arc area process for the joining of the metal with the procedures for the using a special electrode hole for the heating with an arc and maintained with between the two carbon electrode with the filler metal may or may not be used. The process can also be used for brazing. Twin carbon electrode hole is designed for the one electrode movable that can be touched against the other to initiate the arc. The carbon electrode with the help in the holder means for the set of the screw that are adjusted that they are protruded equally with the clamping jaw of the two carbon electrodes are brought together. The arc is struck and established between them. The angle of the electrodes provide the arc that forms the front of the apex angle of the fans out with the softness or for the concentrated heat of the arc of the softer than of the single arc carbon arc. With the temperature of this arc flame is between 8,000 and 9,000 degrees Fahrenheit. Alternating current is used for the twin carbon arc welding. With the alternating current of the electrode will burn off the disintegrate at equal rate. The direct current can be used, but when it is electrode connected to the positive net terminal should not be one side larger than the electrode connected to the negative terminal to ensure even disintegration of the carbon electrode. With the arc gapping space between the two electrodes must be adjusted more or less continuously to provide the fan shape arc. Our twin carbon arc can be used in any application in addition to the form of the welding, brazing, soldering. Can be used for the heat source to blend and form metal. The welding current setting of the schedule of the different side of the lecture shown in figure 1011. The twin carbon arc method is relatively slow. Does not have much use as industrial welding processes. Three carbon arc cutting is an arc cutting process which the metals are severed or melting of the heat of the arc of the carbon electrode of the base metal. The process depends on the heat of the input of the carbon arc with the metal with the gravity cut of the molten metal with the fall away. They produce the cut of the process of the relatively slow result in ragged cut or used only when other cutting equipment is not available. And then I'm just going to look at this a little quickly and we'll see what's up until the next section. Alright, well, we're going to cut the tape right there because I'm skipping around. I didn't skip anything, but, like, it's, getting late. And we're on page, 422.